Have you ever been driving down the highway next to a dump truck, cement mixer, or heavy hauler and noticed something that doesn't quite add up? The truck is massive, loaded with steel or gravel or wet concrete. The suspension is working hard, everything looks heavy and stressed, and yet one entire set of tires isn't touching the road at all. They're spinning freely in the air, rolling along like they forgot what their job was. For a second, it looks like something is broken. Maybe the suspension failed. Maybe the truck hit a bump and never settled back down. But that floating wheel isn't an accident, and it isn't a shortcut. It's a deliberate engineering decision that affects road damage, fuel consumption, tire wear, turning ability, toll costs, and even how long the truck itself survives. By the end of this video, you'll never look at a ghost wheel the same way again. If this channel helps you see everyday machines with new eyes, make sure you stay connected by subscribing so you don't miss what's coming next. The floating wheel only makes sense once you understand how roads actually fail. Most people think roads break because trucks are heavy. That's not wrong, but it's incomplete. Roads fail because of pressure, not just weight. Civil engineers have known this for over a century, and, well, it's the foundation of modern highway design. The Federal Highway Administration has repeatedly explained that pavement damage increases exponentially with axle load, not linearly. In simple terms, doubling the weight on an axle does far more than double the damage. It can actually increase it by several times over. This is why truck regulations focus on axle weight limits instead of just total vehicle weight. A fully loaded dump truck might weigh over 70,000 pounds, but what matters to the pavement is how that weight is spread out. Put too much load on too few axles, and honestly, the asphalt doesn't flex and recover. It cracks, deforms, and eventually fails. Engineers often compare this to walking on soft ground. A person in flat shoes distributes their weight over a larger area, but a person in heels concentrates it into just a few square inches and sinks. That's the first clue to understanding the floating tire. It exists to change how weight is distributed, not because the truck always needs it, but because, well, sometimes it absolutely does. The extra axle exists for heavy loads, not for everyday driving. The tire you see hovering belongs to what's called a lift axle. Depending on its position, it may be referred to as a pusher axle when it's ahead of the drive axles, or a tag axle when it's behind them. Its entire purpose is to share the load when the truck is carrying something heavy enough to exceed legal axle limits. When a dump truck is fully loaded with gravel or a concrete mixer is full of wet concrete, the truck's main axles alone cannot legally carry that weight. The solution isn't to make the axles stronger. The solution is to add another axle, so the weight is divided among more contact points with the road. Industry publications like Truck News and Heavy Duty Trucking regularly point out that lift axles are one of the most cost-effective ways to increase payload capacity without redesigning the entire vehicle. When the driver flips a switch in the cab, airbags connected to the lift axle inflate. This pushes the axle down until its tires meet the pavement. Now the truck has more tires carrying the load, lower pressure per tire, and, well, compliance with road laws. The floating wheel comes down only when physics and regulations demand it. Keeping the extra tires on the ground all the time would quietly destroy the truck's economics. So, why not just leave the axle down permanently? If more tires protect the road, why not always use them? The answer is money, and not in a vague way, in very specific, measurable ways. Heavy truck tires are, well, pretty expensive. A single commercial tire can cost several $100s, and honestly, a full set represents a major investment. Every mile a tire rolls under load causes wear. Even when the truck is empty, those tires are still scrubbing against the pavement, still flexing and still aging. Then there's rolling resistance. Every tire touching the road creates friction that the engine has to overcome. According to data cited by the United States Department of Energy, rolling resistance can account for up to a third of fuel consumption in heavy vehicles. More tires on the ground means more fuel burned for no operational benefit when the truck is empty. Fleet operators know this well. Industry analyses published in Fleet Owner magazine consistently show that lifting unnecessary axles when running empty or lightly loaded can result in measurable fuel savings over the life of the vehicle. Over hundreds of thousands of miles, that difference really adds up to tens of thousands of dollars per truck. The floating tire isn't laziness. It's, well, efficiency. There's another factor most drivers never consider because, honestly, they don't have to. Tolls. Many toll roads and bridges charge commercial vehicles based on the number of axles in contact with the ground. This isn't arbitrary. It actually reflects expected road wear. If a truck is empty and running with an unnecessary axle down, it may be classified as a higher axle count vehicle and, charged more. By lifting that axle, the driver legally reduces the toll classification. This practice is widely documented in transportation policy discussions and is explicitly accounted for in toll system designs across North America. Now, this doesn't mean drivers are cheating the system. Actually, the system is designed with lift axles in mind. It recognizes that an unloaded truck just doesn't impose the same stress as a loaded one, and, well, the floating tire is part of how that difference is signaled. Turning a long truck with too many axles on the ground creates a different kind of damage. When a vehicle with multiple fixed axles turns, not all the wheels can follow the same arc. Some are forced to slide sideways slightly as they try to keep up. This sideways dragging is, known as tire scrub. It's loud, destructive, and incredibly hard on both the tires and the suspension. Engineering studies referenced by the Society of Automotive Engineers have shown that excessive scrub dramatically accelerates tire wear and increases stress on axle components. It also damages pavement, especially in tight turns like loading yards, construction sites, and urban intersections. By lifting the extra axle when it isn't needed, the driver effectively shortens the truck's wheelbase. The truck becomes more willing to turn. It pivots instead of fighting itself. This reduces stress, noise, and wear in ways that matter every single day. What makes this design impressive isn't just that it solves one problem. It solves several, depending on the situation. Loaded truck on the highway, axle down. Empty truck heading back. Axle up. Tight turn into a job site. Axle up. Long, straight haul with weight to distribute. Axle down. Modern lift axle systems are often controlled automatically, adjusting based on load sensors and speed. According to manufacturer documentation from companies like Hendrickson and Meritor, these systems are designed to optimize traction, braking, and stability while minimizing unnecessary wear. This isn't a static machine. It's a shapeshifter, constantly balancing physics, law, cost, and practicality. The floating tyre is a reminder that good engineering often looks wrong at first glance. To someone who doesn't know what they're looking at, a wheel not touching the ground looks like a failure. To an engineer or a driver, it's a sign that the truck is doing exactly what it should be doing. It's saving fuel, it's protecting the road, it's reducing wear, it's improving maneuverability. And it's extending the life of a machine that's expected to operate for decades under extreme conditions. These are the kinds of details that surround us every day, hidden in plain sight. Ordinary machines quietly doing extraordinary things because someone took the time to understand the problem deeply and design around it. If you appreciate learning how the everyday world actually works, take a moment to subscribe and share this video with someone who would notice that floating tyre, but never know why it's there. This is Simple Things Explained, and there's always more going on than meets the eye.